Good evening to all. The fifth day of this 7 days FDP program on the research methodology, bibliometric analysis, and data analysis using R. So, before Nandita ji will introduce our speaker, Dr. Soumik, just I will give the one small 1 minute introduction about this statistical software R. This is actually very powerful software R, and nowadays researchers are using this software very widely. And we can do create different kind of packages by using this software, and we can publish also, and it is free also. So next 2 days are very helpful for the learning this R studio and R. So please try to give more and give attend properly, and later on we will share some exercise material also for practice purposes. So over to Nandita ji.
Hello.
Yes, 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 you are audible.
Okay. A very good evening to all of you. I, Nandita Sikarwa, welcomes all the participants, professors, scientists, research scholars of UGPG on fifth day of 7 days faculty development program on research methodology, bibliometric analysis, and data analysis using R. The FDP is organized by Society of Education, India, University of Agricultural Science, Raichur, Karnataka, European Laser Academy, Germany, Genome Biotech, Mathura, in association with Office of the Principal Advisor to the Government of India under Waste to Wealth Mission. Here, we started the session for the fifth day of FDP. I feel great honor to invite Dr. Soumik Rai, Assistant Professor, Centurion University of Technology and Management, Odisha, for giving his expertise on introduction to our software and its overview to all of us during fifth day of faculty development program. Before starting the lecture, I would like to give a brief introduction of Dr. Soumik Rai, sir. Dr. Soumik Rai is an assistant professor at the Division of Agriculture Statistics, Centurion University of Technology and Management, Odisha, India. He completed his MSc and PhD degree with National Fellowship in Agriculture Statistics from Bidhan Chandra Krishi Vishwavidyalaya, West Bengal, India. Dr. Soumik Rai has received the NCRTNF Base 2020 Young Scientist Award in Agra, India, and the Base Young Scientist Award during an international conference organized by Base Biology Agriculture, SciTech, and Agriculture Conference Association ICEG TABPS 2021 in India. He is a life member of the Society of Economic and Development POA and India and the Society of Application of Statistics in Agriculture and Allied Sciences BCKV India. He has a number of research papers published in prestigious national and international journals. Over to you, sir. Please start your session.
Sir, you are not audible. Please turn on your mic.
Yeah, yeah.
Yes, sir.
Am I audible now?
Yes, sir.
Okay, okay. Okay. Thank you, the organizing committee, for giving me such a great invitation for giving some session talk on uh, 7 day faculty development program on research methodology, bibliometric analysis, and data analysis using R. And good evening to all participants, the academic person, the researcher, the professor, and uh, others, PG and UG scholar. So I'm covering the portion that is the introduction to the R and its overview. Okay. So let's share my screen. There is some error, I think. Okay, is my screen visible now?
Sir, but there is
Is my screen visible now, right now?
Yes, sir.
Okay, okay. In this slide, I think this slide is visible to you all. Okay. So about the introduction, let's as because of we are all a academic person and a researcher, as you all know, data analysis is the most important part a researcher because of we have some information and we have to analyze the data based on some uh, objective, right?
Soumik, I think you have to little bit minimize first. Slide size not visible.
Okay,
Your screen is visible only. Google Meet screen.
okay, can I, slide is not visible.
No, no.
sir, restart your presentation.
Okay. I think some issues. Wait a minute. Now is the screen visible? The slide.
Yes,
Yes,
yes.
yes, visible. Yeah.
Okay. 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 So as I said that data analysis is the most important because as a research person, we have some information and we need to analyze our data based on our objective, right? So and also it is very important to choose a software tool, right? So in a researcher or as a data analysis, it is most important to decide which software he have to use for data analysis. Now, in the market, in our global market, there are several software for data analysis. Some paid version are there and some open versions are there. Open source software is there. So as you can, this is the paid version. Some is as we I think you all know SPSS, SAS, Minitab, Stata, MATLAB, eViews. They are all are powerful software, but they are paid service. They have some subscription. so that we are not using the total uh, fu- total analysis, or some of the portion we are not using because of we need some or we need some institutional subscription. But the open source software like R, Python, we are doing uh, vast use in this software. We can use with our own criteria, with our own function. If we develop any function or if we develop any formula, we can easily incorporate with them with this software, and we can run it. Okay, so it is a most powerful thing. Okay, next, as because of we are talking here, that is the based on the data analysis in the R. So it is very important. What is R, right? It is a open source platform where we can easily download, where we can easily use that R platform. Now, the talking about who developed that R, right? This is the two person, Rose Iraka and Robert Gentleman. These two person are developed the R software in the early 90s. Okay. After that, the R totally uh, followed through the R Foundation of Statistical Computing. They are taking over. This R team is taking over that R software, and day by day they are developing. Okay. So this is the small overview. What is R, and who are the introduce this R software or R platform or R programming. Okay. Now, why R? Why are we are talking about this R, right? So see, R is not a platform for a statistical purpose. It is a platform for a different purpose of a computer science, any sciences. Okay, as because of it is an open source platform. Also, R is available in different operating system like Windows, Unix, Linux, and Macintosh platforms. Okay, and the most important part is the graph obtained from the R platform or R software. We can easily uh, incorporate in a different format like JPG format, PNG format, as well as the PDF format, because most of the paid service that SPSS says, the graph obtained from that platform, either they are providing JPG or PNG. They are not providing any PDF format. But here, the R gives us our graphs, our different graphs in a PDF format. It is a most uh, uh, useful researcher. Okay, as well as I said that when if we develop any function or any formula, very simple word, I can say that if a mathematician or a statistician or any researcher develop a function or formula, we can easily program in the R platform, and we can build our own package or our own function. Okay. Later on, I will give you one small example how do you build or how do you make a function on your own. Okay. So that's why we can use the R platform. It is very easy to use. Okay. Next, the installing of R. Now, some of the researchers are fear about that it is R programming, or are say that yes, it's followed the machine learning, all this. No, not at all. It is very simple to install and very simple to use. But you have to know some tricks. That is the tricks, or you have to follow some step. Okay. So installing a R software, how to install. So as you can see in my slide, so this is the site. Okay, let's open that site, or I am just demonstrate here. I'm just giving you one example. I think this screen is visible. I'm just close all this tab in Google. I think this browser is visible to you. All right, in
Yes,
this
sir.
Google, I'm just writing R.
Maximize. Sir,
Okay,
please
nothing to.
maximize it.
Okay, I'm just in Google, just type R and run. Directly you get this the R project for statistical computing. Okay, so just click here, it will open. Okay, this platform. Now here you can see the download R. Okay, now click here, then open the project version as well as some mirror version. Mirror version are generally authorized based on different country. In our India, there are, if I go to and search the India, where is India? As you can see here, see India is there, and the India two institutes are authorized for the R mirror. What is this? That is the International Center for Theoretical Science and National Institute for Science Education and Research. These two institutes are have the mirror of the R project. Okay, so you can directly do, uh, click here, or else you can use that based on your country. You can use that link. Okay, and if you click here, you get that information about download and install R based on your operating system. Here, Linux version is there, Mac version is there, as well as Windows version. Based on your operating system, you have to click. Okay, so let's do this in the Windows because of maximum of us. We are using the Windows. So Windows, then install for the first time. Okay, when you click here, see download are the latest version are 4.3.1 for Windows is there. Okay, after clicking here, one file will be downloaded. Okay, after that, you have to install like very simple way that Microsoft or any software. How do you install? Very simple way, you have to install, or you can install this very simple. Okay, so this is the process. I just make a screenshot and give an overview regarding the installing the R. I think Pradeep sir already shared the brief way how to install that R in a doc file in your group. Okay, next is installing R Studio. Okay, now before talking about the R Studio, I am talking why R Studio is developed. Okay, instead of this R, right? So I have the R software. If I run this is the R. Okay, I think this screen is visible to you. This R console. Okay, this is the platform. This is the early 90s that Ross and Robert developed only this platform. Okay, and if I calculate, it is easy to use. Nothing. 2 plus 2. What is this? That is 4. I am just running and get a 4. Okay, 2 plus 3 plus 4. Okay, running, that is 9. Now the thing is, if I get mistake any typo error, if I get any typo error in any command line, I cannot edit that one. Okay, that's so it is very difficult to use not only a statistician but also not only a researcher, a general researcher, but also a statistician or mathematician. Because of every time he have to remember that function, and if he or she have any typo error, he have to start again or he have to write the command line again. Okay, so to overcome this situation, the R team, okay, R team developed a eco-friendly platform. It's called the R Studio. Okay, and that platform are uh, run by the CC programming language, C++ programming language. Okay, so this is the link where you can download R Studio, and it is very easy to use. And we are later on we are only use this R Studio platform. Now, one thing you have to remember that to run a R Studio, RStudio software, you need to install R first, the latest version R first. Okay, without R, you cannot run the RStudio software. Okay, that is the main criteria. Because of, if I say the R is the heart and the body of the R is the RStudio. Okay, so how do you download? Nothing else. In Google, just you have to write RStudio. Okay, then you get this RStudio desktop. Okay, and it run. So this is the interface you can get. As because of mine is the Mac, so that it's like this interface. Some Windows version or a Linux version, maybe you can get the different uh, interface, but nothing varies. It is very easy. See, with the you can install R from here in this platform also, or you can install R from the separate one what I show you earlier. Okay, and install RStudio. Now see in this platform, as because of this is the Mac, the RStudio, what they do, they are finding which operating system search us. Okay, and based on this, they are giving a recommended version for Mac. Okay. Otherwise, you can, if you scroll down, you can see for Windows 10 and 11 version, you can download this. For Mac, for Ubuntu, that Linux and other operating system, whatever you can use. Based on this, you can download all this and you can run. You can install. Okay. And the briefly installation of the RStudio already given to you, maybe that doc file. Same process have to follow and you can install this. Okay, now anything issue regarding that installation of the R and R Studio, you may ask in the end of the session. Okay, so this is the platform. Now running R is nothing that run a R, and this is the console. Already I think you see this is the console. Okay, and the command for this is the basic. After opening this, you can cross by clicking this, or for Windows there is a cross section, you can cross, or else you can command Q in the first bracket and hit run. If you hit run, then hit enter for a run, then it automatically go quick. Okay, running a R. Now libraries in R, now it is a very important. Okay, what is libraries? See, R offers a wide range of function. Now, what I say earlier, that we can develop our own function. So, the similar way, different researcher or different scientists, they are making their own function, and they are not they are certified. Who certified? That our team already certified that function and build some package. Okay, and what is library? Library is nothing. Library organize that function and that database and that package. Okay. So to run a library, what is the command? Okay. So there are small thing we have to remember, or else we can note down that one. We can easily remember this one. Later on, it is very easy to us to write a command line. Okay, so nothing, that is the library in first bracket. This is the basic command. Okay, now how to organize a package? Let's say to load a package means I am use this package in my software, in my R Studio. I have to install some package and mm, uh, keep that package in the library. Okay, so very simple way. Let's say this is the T series one package is there, vastly used package is there. Okay, in the next session or next day session, in the time series session, maybe you are using this package also. So it is very important package, that is the T series. How to organize? That is the command library T series. Okay, then either run one icon is there in the R Studio. I will explain one by one. Okay, either you click that run icon. This is the icon. Okay, or else you can use Control plus Enter. Okay, or return for Mac, so that package will be installed in your library. Means it will be active for users. Now different package, the base package of the R, because there are some different base package are already installed when you install a R and R Studio. Okay, so this is some basic example about the MAS and MAS, that is the modern applied statistics, which is developed by these two scientists, uh, Vanabel and Ripley. Okay, MGCV, that is a mixed GM computation vehicle. This is a one first use a base package which is already installed, already come with your R Studio. Okay, GB drives, GR drives, that is the graphics drives. Based on this drives, these drives are helps to incorporate with the graph. Different graphical parameter are used for the for using for running the R platform. Okay, now installing package. I am talking about first the library. We have to differentiate which one is library, what is library and what is package. Package is nothing. What I say, that T series. I gave one example. This is the package. This is package nothing. In this package, different function is there. Different formula are incorporated. Okay, and that function are developed by the scientists. Okay, so that package I have to install in my R platform. Then to active that package, I have to use by commanding the library and T series. Okay, so to install that package, nothing, very simple. There is a command, that is the install.package, and which package you are need. I am giving one example is this T series. There are lots of packages based on the different analysis. Okay, and later on I will give some example which I'm giving you some packages which is used in a day-to-day our research life. Okay, so this is the command install.package. Another way you can install the package in the R platform, R Studio. I will show you one by one later. Now, talking about script and command line, there are two main mm, terms. That's it. Generally, we are overlapping that common. What is command line or what is script? We are making some mistake. Command line is nothing. Command line, I think this R console is to you, is visible to you. See, this is the command line. Okay, 2 plus 2 equals to 4. I am in the command line. I am giving uh, 2 command, that is 2 plus 2, and the result gives me a 4. Okay, this is the command line, and this the drawback in the command line is we are not editing, or if any typo error is happen, we are not edit at that command line. Okay, so this is the main drawback of the command line. And what is script? Script is a section where we can write a command line, we can write a text, we can write a story, everything. That is the section, that is the script. Okay, so very important, command line also be written in a script. Okay, So this is the basic difference between the script and command line. So in this slide, you can see here, this is the interface of the R Studio. Okay, and there are four windows. We'll talk about one by one. So this is the portion that is called the script section. Means this is the part where you can using as a script, and command also written in this script section, and there is the command. Okay, so this is the basic difference between these two terms. Then our studio we are talking about, because of I'm saying that later on we are doing all the analysis in the R studio. Okay, now R studio is an integrated development environment. Okay, and it's run through the C++ programming language, and it is very easy to use for a beginner or a pro also. Okay, now RStudio offers several essential tools and features that enhance the R programming experience and streamline of the data analysis workflow. Okay, so in the RStudio, we are using different type of tools. Okay, and also we can connect other software also. This is the very important thing, because of when suppose I am doing one analysis in the SPSS. Okay, and later on you are know about some R, and you learned and you are most like this software, but some of the portion you already done in the SPSS. Now how do you incorporate, how do you import that one? Okay, so R connect the other software also in the Python, in the SPSS, in the SAS, all uh, the the R platform connect all the software to make it easy to use and easy to analysis. Okay, now is the interface of the R Studio. That is the there are four windows. Okay, let's say this is the window 1, window 2, window 3, and window 4. Okay, now let's talk about one by one for window first window. This is the script section, as I said also, and you can also write a command. Okay, now you can also add new script by using this, by using this. Okay, uh, is this point clear out? That small point is there, our script. I am moving this point. Is it visible to you, or else I am opening the PowerPoint?
Visible, sir.
Okay, okay. So by clicking here you can get this information. So new R script you also incorporate. Okay, and also you can use the text file, CC plus file, Python script, SQL script, all this you can use in this first window. Okay, now you can save. This is the icon. Okay, save the script by clicking this. Very simple. This is the, we can save by clicking this icon. This is the run icon. Okay, the run command, or a set of command. If we want to run a set of command, means set then what to do, we have to select all the command, then hit this run, click this run button. Okay, or else you can directly use your keyboard by control and enter, or command and return. Okay, and this is the rerun, means suppose you get the you again want to get the same result, or else you have some typo error, then you just edit that portion and run it or rerun it. You can do as your own. That is the case. Okay, this is the function of window first window. Next, the second window. Second window, what I say, this is the console. This is the console window. In that console window, that is we are only using the command, and we can get all the calculation result. Whatever we calculate, the result will be given in this window. Okay. And as I said earlier, that it is possible to write program in a console as well, although can be make changes and experiment with the coding after run the program. It is sorry, it there is some typo error. It is not possible. It will be okay. Later on, I will change this. If you want this slide, I will share later on. No issue. Okay. Now window 3. In this window, this is called the environment window. This window. Okay. Now in this window, all the variable and objective are shown in this window. Okay, and as well as the data of the values of the variable, means the data obtained from the variable also given in this window. Okay, now let's talk about this window one by one. Also, the information about the variable also you can save by clicking this one. Okay, save workspace. Now earlier I've said that uh, okay, importing a data. Okay, you have to import some info data set, right? So you can import from by clicking here. Also, there is some command line, or there is some command to import a data set. I will explain one by one. This is the history, means you can get all the codes, all the commands which you used earlier. Okay. Now this is the clear icon. You can clear all the objects in this environment. And tutorial, recently this tutorial are added in the RStudio. In this tutorial, you can learn some basic programming. Okay, if you click here, you can get some search option, and if you want some know about the packages, or else if you want how to use that packages, then you can see that tutorial, and then you can easily run or use that package. Okay, that is the window 3. Now talking about window 4. Now in the window 4, this is the file. Okay, in this file we are getting the information about the directory. Now what is directory? Directory is the nothing. It is the location. It is the location where our R is working. Okay, in a computer, there is desktop, there is C drive, there is D drive, there is F drive. So you can use you can prefer your own drive and make a directory, means i want to I want to uh, run the R in this location. Okay, so that uh, you can make a directory with the own. Okay, so from the file you can see where the directory is working, means what is the current directory is working. Okay, now see in the plot get all the plots output. In the plot you can get all the outputs about the different graphs. Okay, now packages. Now see in this portion you can get all the information about the package installed in your R studio. Okay, all the package means whatever package you installed earlier and whatever the package are already installed in your R when you install your R studio. Okay, the information gives in this portion. Okay, now helps, get helps. In this portion you can get helps in different packages functions. Okay, now viewer is used to get a larger version of your graph. Okay, if you want to zoom and you want to check that which portion you want to check some graphical portion of your graph, so you can zoom it. Okay, and that zoom and zoom in and zoom out are uh, are mm, care of this viewer section. Okay, and presenter means whatever we present or whatever you get the result, the environment, the variable information, that graphical information, that is the, as because of, as I said, C++ programming language are used for this running of RStudio. So presenter is present all the information in a single interface. Okay, so this is the all over four window information of our studio. Okay, let's see another thing in the window, packages. See, all the package information is given. Okay, now think, see, if I click here, okay, if I click here, that means I am giving this package in a active mode, means I am giving this package in a library. Okay, in my library at the present working flow, I am giving this in a active mode. Okay, so this is the way, or else there is a command, as I said earlier, that is the library and the package name and the run. It will be automatically active. Okay, and also you can install, as I said, that there is a command that install dot package and the package name. Okay, or else you can install from this window 4. This is the icon. If you click, one interface is given below this. Okay, and if you search which package if you want to install, here as an example is given as ggplot2. This is also a powerful package. Okay, ggplot2, then select, then hit here. Okay, install, then it is automatically installed in your R platform. Very easy to use. Okay, and this help section is nothing in this search bar, or search bar. If you want to know about the packages, codes, and any other functions, just write and you get all the information. Here is the example, bar plot is written, information about the bar plot is given, the code about the bar plot, and also all the descriptive are there. If you scroll down, it is just a screenshot, that's why I'm not able to give, or else I'm just giving one example here. Where is my- okay. There is a R Studio. Okay, is this screen visible? That R Studio platform?
Yes,
Oh,
Visible, sir.
visible.
oh, oh. So see, in help, I'm just writing at hist, hist. Hist means nothing. That is the short form of the histogram. I want to know about the histogram of the histogram package. Okay, so hist. If I click here, see, information about the histogram is there, the description, the uses, the code, the syntax. Generally, it's called a syntax of the histogram. All the sub syntax information are given here. Okay, as well as you can get some example also. See, very important is this. If you don't know about some packages, if you search to get the information and how to uh, get an example, so that it is easy to you to use that one. Okay, and the different example is there, you can easily get. Okay, so I'm just crossing this, no need to this, just make a q in the first bracket, and if we hit run, it will be the quit option is there, don't set. Okay, no need to this r right now. So next question is the data importing and reading. Okay, now how to import our data set, because of it is very important to analyze our data. If you do not know about the how to import a data in the R platform, then next, what to do next? How to analyze our data, right? So it is very important, and as well as we have to check the data. That is called the reading. Means I am just making as a you can say in statistical term you can say the descriptive statistics. Okay, to check the nature of the data and the reading. Now, see, this is the in this slide for a window operating system. This is the traditional case to check a directory. Now, I'm talking about the directory. As I said earlier, directory is nothing. It is that means the location where the R programming is working and the R file will be saved. That is the directory. Now, before importing or before running our software, our running the data analysis or analyze our data in the R platform, we have to set our directory also, because if we do set a directory, it is easy to uh, use or easy to find, easy to get the all the result like graph, then information, then variable information we can get uh, that directory. Okay, so how to set a directory? Now, this is the traditional command, very long earlier it is used, as of now also used, but this is the very traditional. Okay, because first you have to set a location, then you have to remember this set wd, and then you have to remember that from the c to location means c drive. Then I think you all aware about when the operating system are installed, in the c drive there is a program file, right? Another one is program file 86, means based on the version. In the program file there is office, in that office there is excel, there is, that means that excel file installed in the program file which are located in the c drive, right? So likewise you have to remember and then go and you have to write and run, right? So this is the very traditional way. Whatever I did and or whatever I do, okay, to set a directory, it is very easy to use. So see, this is the uh, case. Now see, in the file there is a, you can get the new project. In that new project, if you hit run, then you can get one pop-up box. In that pop-up box it's written as new directory, existing directory, version control. Okay, I want to make a new directory or new location to work my analysis. Okay, so new directory. In this new directory, you can get all the information, new package, R package, all this. Sorry, new project. Okay, in this new project, if I hit run here, then I can get another pop-up box. In that pop-up box, the directory name. In the directory name, we have to write our name, rename of our directory, and the browse. We have to browse that location where I want to work. Okay, so this, and then create project. Let's do one example. Okay, let's suppose I make a folder here first. I think this desktop is visible to you. Folder here as a R. Okay, I make a folder. Okay, now in this R, I go to new project. Then okay, I'm just make a save new directory. Is it visible that pop-up box new directory is there? Is it visible to you?
Yes, sir, visible.
Okay. So new directory, then click, then new project, then again click, then got the pop-up box is appear, and I'm just writing the FDP of FDP, okay, and browse. Where I have to go, I have to find in that desktop. In that desktop, I am making that folder. What is that folder name? That is the R. This, okay, and open and create a project. Create a project. See, new directory is open. New project is open. Okay, so this is the platform. Now see, if I click here, see FDP on R, the folder name and the directory is mentioned. Very easy to use. Now, let's see. After making a directory, now imported R. Now, R in the R platform, we can import different types of file, either CSV file, either Excel file, either TXT file, either HTML file. It is very another most interesting part. From the internet also we can import our data. Also a SPSS file, Minitab file, SAS file, everything we can import in the our platform. Okay, so let's talk about one by one. Now, first talking about the mm, uh, import of the what I say from internet, that HTML. Okay, so as an example, I this is the okay, minute, rice production in India. Okay, just I am just search here. I'm going to search here. So, in India. Okay, Wikipedia. Let's check it out here. There's some data, right? There is some data, isn't it? So I want to import this data in my R and want to do any other analysis. Okay. Now, how to import directly from the internet to this R platform? Yes. Anything else? Okay. Some noise is coming. That's why I'm no issue. Okay. So this is the link. Okay. If I'm just copying this. Okay. Now, how do I import? Now, see. Let's talk about to import a data from the internet. From the internet, we need some special package. Okay, if you use the first time of your data R platform, you need to install all the package. Okay, some basic package. In also you can get that information in the internet. How to import from this internet? How do you import the package from CSV file, TXT file? In the internet, they are giving, and as well as they are recommended some packages. Okay, and also you just if you import that package, install that package, and then library that package, then you can easily do. Now see, this is the package name, rvest. Okay. Generally, others package also there. Okay. Generally, whatever I use, I'm just saying that I use rvest, that package, to import data from the internet. Okay. Let's do this. I already have this rvest. I installed that rvest. Where is this? This. Okay. I'm just I want to active so that library are this. Okay, and it's done. See, The difference, this is the script section. I am making the script, and also the result given means I am running this, means I already done this. Yes. Okay. Now next I have to import. So df equals to read. That is the, this is the some command, read HTML. Okay. Then I have to paste. Okay, sorry. I have to copy here, na? Control C. Then semicolon control. C. V. Okay. And runs. And runs. Okay. So see, two list of our df means I'm just giving us some small name, that is the data frame. Okay. Now if we hit run, if we click here this environment, if we click here, we will give some like this information. Okay, because in this two list there is two table. Okay, now how to find that table? Okay, so let's write table one equals to, so here the command is given. Okay, so see first, to incorporate that two table, have to use this df as a command to use that two table. Okay, so table equals to df this command html table fill true. Okay, so let's do df, then percentage, then percentage, then html ml table. Okay, then html table, then fill equals to true. True. If I hit run, I got a table list. Okay, how many tables is there in the cases? There is 5 tables. Okay, let's check it out one by one. Table table 1, okay, table 2, the giving one. Table 1 double column first table. Okay, I hit run. So let's take table 2 information. So see, we can get the information about this. Exactly same, whatever we get in this serial number, year, production, yield, all this information is there now. First table. In that first table, also I have already get this. Got it? So very simple, but slightly you have to just remember some command, some code. Okay, nothing. That's it. Because, and it is very easy, because our platform is very easy to use, because of, as I write here, I can share easily to you. Okay, other paid service, that SPSS, Minitab. Okay, whatever I do, whatever I make a script, it is very difficult to share to you. But the R as well as the Python also, we can I can easily share to you this file also. Okay, so this is the way we can import the data from the internet, uh, from the internet. Okay, next is another file, CSV file, Excel file, TXT file, SPSS file, all of this. Okay. In that case, one command are sufficient. What is that command? I will give you the example about the CSV file, TXT file, all these things. Okay. Now listen carefully. Whatever I personally use this command. Okay. There are different technique to import a data set in the R platform. Whatever what I do. Let's say this is data frame name read CSV, the command file dot choose. If Excel file is there, read Excel file dot choose. If TXT file is there, read dot table file dot choose. If SPSS file is there, read dot SPSS file dot choose. Now the thing is to import the Excel file, you need to install read Excel package. Okay. To from to import the SPSS file, you need to install the origin package. Okay. For TXT file and for CSV file, inbuilt some base package are used. So that's why you need not to install any special package for CSV and TXT file. Okay. So let's do let's install one CSV file. Okay. In example, let's say df2. Df is there, df1. Okay, equals to df is nothing that data frame. I'm just written like. Now see another thing I have to mention here. I'm generally doing as a equals to. It is also equal in this sign, means less than or hyphen. Same command are there. Okay. Generally, I prefer equals to. It is easy to ask to incorporate. Okay. Now what I say read dot CSV. See already is there. Okay. Nowadays our uh, R strip, when you write any R strip like this, I am just writing R dot only C. They are giving some recommendation. Okay. Earlier it's not given. Nowadays it's given to you some recommendation. If you not given any recommendation, if we hit tab, okay, just listen carefully that after read dot, then if you hit tab, okay, the recommendation are given to you. Okay, based on your criteria, you can choose. Okay, I am choosing the CSV file. Okay, then first bracket. What is the command? File dot choose. So already it's given and hit run. I'm clicking this run or else either clicking this run or else I'm using the keyboard, that keyboard control plus enter. Okay, control plus enter. Now see one pop-up box are open. Now here listen very carefully that some of the Windows platform initially this pop pop-up box is not open foreground of your R studio. It may be open your background. Okay, listen carefully. This pop-up box are may be open in your background of your R software. Okay, this is the R software. This blur portion, right? This is the R software, and my pop-up box are open in the foreground of the R software. Some of you maybe you some of the cases these pop-up box are open in the background. I'm repeating twice. Okay, at that time if you not shown that pop-up box, just minimize your R. Okay, check your desktop, definitely you get that pop-up box. Okay, now now in that pop-up box I am finding a CSV file where I am putting my CSV file, this RFDP. Here one CSV file is there. Okay, I'm just input. Okay, if I okay got it that desktop FDR in this folder I have one CSV file, that is the data CSV file. Okay, this is some information I have to open and got it. So df1, so if I check df1, the information is given to you. So see, this is the information. Okay, so there is some warning message you can get, nothing worry about this, because of I this directory is working in the R folder, right? And I import my data from the another folder, that's why it's given like this information. Okay, so this is the information. Now this is the way we can import the CSV file. Now see, okay, I'm just clear this one and again I'm running it. Okay, now see, in the first row 10x 10 15 10 20 is given. Okay, so I can rename this one also. Okay, how do that is name names df1. Okay, this is some small command, means I have to rename in my first row. Okay, so rename equals to c. C is nothing, c is the combine in the first bracket in the first row, that is the, let's say in the first column I want to named as a x. Okay, comma, in the second column I want to named as a y, and the third column I'm going to name as a z. Okay, if I hit run, then df1 df1, then hit run, see, x y z is there. Okay, very simple. So this is the way you can create a name or rename your row. Okay, row column. So this is the import of the CSV. So here given some example from the CSV file. Here header false or header true, you can choose your own perspective. Nothing can use this, or else you can use, because of I am not giving the see, this is the file actually whatever I import, this is the CSV file. Okay, and in this header no named is there. Okay, that's why header false to be given. By default header, the syntax given the header is true. Okay, so that's why what they give, the 10 15 and 115 treated as a name. Okay, so as you can see here, 10x means first variable, second variable, and third variable treated as a name. But this is not a name. If I again that portion I want to, if I run here header and false, false, and if I hit run again, okay, then again I have to import this. Let's say import from the desktop R and CSV file, open that one. Okay, and again if I hit run, let's say it is this this one I want to run. See, v1 v2 v3 here, 10 15 and 150 treated as a data. Okay, so because of there is no header, so that's why I am just command my line that header is false, no header is there. Okay, and if I run this again, rename, and again I am run this here, so here x and y, x y z is there. Okay, now this is the CSV file. Same way you can import a txt file. Same read.table. There is a txt file, text file. In that text file also, and there is a special command that separate. Means in the text file, they are the filing means space is there, right? So there is no section, no cell is there. So that's why I am just commanding as a separate and giving this information. Also, you can rename this similar way. Okay, and the similar way you can get the Excel file also. Now, another thing is what I say, to import a Excel file, you need to install a package, a special package that is read Excel. Okay, what is that package? Package is this read Excel. Read Excel. Okay, so let's do another example. That df2 equals to read. Okay, because of I am making this, I have this package, but I have to active that package by commanding the library read Excel. Okay, so if I hit run, got it, then read Excel. Excel is coming. Then again file dot choose. Okay, then hit run. Again pop-up box is open, and in the R, where is this FDPR? There is a Excel file. Okay, same Excel file is there, and just open it, and boom, that is df2. df2. Okay, now see, very interesting thing I want to share to you. That is the Excel file, and you can also rename the same way. Okay, now see, some of the dbl table is given here, right? 5 into 3 is given here. So what is this? This is nothing. The the excel file, when we import Excel file, that Excel file give us as a matrix form. Okay, that is called the table. Is another special type of package which is running in the R programming language, which is used to manipulate and print a data frame. Okay, so it is also give a matrix form. Because of our data is a 5:3 matrix form, with 10, 20, 30, 40, 50 like this all, so that from the cases 5 into 3 matrix form they are given, and each variables give 1:5 matrix form. Okay, so if if we want to check the structure of the data, means the information of the our data, we have to need the command that is the strdf. Okay, this df is incorporated from the csv file. One example, df from text file, this from Excel file. The difference is this. Okay, and this is the data frame. In the CSV file, they are given the data frame. For TXT file, they are given the data frame. 5 observations in 3 variables is there. Also in the Excel file, it's also given a data frame, but in the manner of the matrix form, 5 into 3 matrix form. Okay, that is the way we can read the data. Okay, now uh, do some basic analysis to find the mean, standard deviation. So as you can see here, the mean, as because of time is almost over, so that I'm just trying to finish my slide. Almost 2 and 3 slide is there. All the
Yeah,
yes,
Soumik, sorry to interrupt you. Just try
yes sir.
to finish fast because
Yes sir.
next speaker is waiting. Okay, please.
Yes sir.
Thank.
Yes sir. Yes sir.
Okay,
Sir,
thank you.
I have only 2 and 3 slide. I'm just want to see them, because all the screenshot is there, so nothing
Mhm.
worries about that. Okay. So
Okay, thank you.
see, participants, that you can type mean data and a dollar form. Dollar form is nothing. Dollar form separate all the variables. If you want to find the average of these z variables with the dollar form z, then you can get the information. If you want to y, then dollar form is y, then you can get. Similarly, you can get the standard deviation also, okay, by using the SD. And another function, another command also there, that is the summary and total data. Generally, this is the data, another data I am using this, and this is the data, okay, so named as a data in these cases. And summary of the data, you can get all the information regarding this. And another special package is there, okay, this is the package. If we do that package, you can get the first area of the descriptive statistics, like the mean, median, then the skewness, kurtosis, standard error, range, maximum, minimum, all these things, okay. And if you want to do some box plot graph, some graphical representation, this is the command, okay. So box plot data x and y, okay, this is nothing, this is the x and y. In this x and y, you can change the color by using this, okay. X lab, that is the x axis and y axis notation, and the main notation is box plot, so that you can do this. And if we write here horizontal true, then your box plot is given as a horizontal way. If this is the vertical way, okay. And some of this is the another data which I try to give you, that this is the way you can make a data set from in the uh, script, in the script section, okay. Data C this, and you can easily make a histogram. So this is the command data, this call main, then in x-axis this, in y-axis this, x-axis class interval, y-axis frequency you can get. And by using the special most powerful graphical package, that is the ggplot2, if you want use this, and this is some command, you can use this type of graph also with the uh, using of the frequency polygon line also, okay. So, and this is some important package, whatever I am trying to say, that next session, maybe the what is the next session, that is the design of experiment. Maybe these two packages are used vastly, that is the Agricola and DOE.base, okay. Generally it is used, and this is the some example of some packages, okay. And thank you from my side.
Thank you so much, Dr. Soumik, for the excellent and very informative session. And I think participants get very well overview about the R software, about installation, importing the data, and some basic packages. So because we are little bit running behind the time, so Dr. Soumik is already in our WhatsApp group. So
Yes,
there is
anything problem regarding in this last in this section, in this session and coming session, okay,
mm,
you can inform me also.
mm,
I can happy to help you. Anything error you can get, then happy to help you.
yeah. So I think Hannah, this session we are not Hannah taking too much time. So I will introduce to our next speaker, Dr. Manoj Kanti Debnath. He is actually assistant professor in Department
So
of
I'm
Statistics in Uttar Banga Vishwavidyalaya, and he has published so many more than 50 research articles in the national and international reputed journals. And he is a very vast experience about the statistical software like SPSS, SAS, GMP, R, and his area of specialization is time series analysis and design of experiment. So after the overview of this R software, Dr. Debnath will help us to understand analysis in R software use for the design of experiment. So I will welcome to Dr. Manoj Kanti Debnath sir for our
Thank
next
you.
session. Thank you, sir.
Uh, It's Dr. Pradeep.
Yes, sir.
Uh,
Your
Screen
slide
is
is
visible.
yeah, yes, sir. You can make into your presentation. Right now we are seeing your Google Meet screen.
No, no presentation.
No, no, sir. Just minimize this screen, sir.
So it is visible now.
No, sir, not visible. It's blank.
Already shared the screen. Entire screen.
Yes, sir. It is visible now.
Okay.
Slides. Just please make into presentation mode.
Mm, is this? Okay. So good. A very good evening to everyone. So first of all, I'd like to thanks organizer for giving me the opportunity to deliver a lecture in this faculty development program on research methodology, bibliometric analysis and data analysis using R. So before going to the hands-on training, I'll briefly explain the different designs and what are the important thing we should know about design of experiment. So first of all, we should know what is designs of experiment. Actually, designs of experiment we means here how the observation or measurement we should take, okay, to obtain a valid, efficient, and economic means output, or we can say to answer a problem or answer a query. So design of experiment broadly we can divide into three parts. Okay, first is we have to plan the experiment and obtain the relevant information. Then after that, we should do the statistical analysis of that information. So based on this statistical analysis, we have to draw the inference. So if your experiment, if it is not well designed, then what will happen? So whatever information or the statistical analysis, after getting the statistical analysis, so whatever result you will get, and based on the result, whatever inference you will draw, it may be questionable, or sometimes it may be invalid. So it is very important, and to make your experiment and well designed. Okay. So there are three principles. We all already aware of this: replication, renovation, and local control. So this thing everyone already knows. So I think no need to explain. So among these three, I will explain one simple thing, that is this regarding the replication. So that is very important thing for any experiment. So we always confuse how much replication we need. So for this, so here we can see one graph plot is there. In this plot, one side there is a F value. F value means this is a critical F value. We can say it is a tabulated F value, and one side and x-axis there is a degrees of freedom. So from this graph, we can easily observe that, see, after 12 degrees of freedom, this line become stabilized. So before the 12 degrees of freedom, this line is not stable. So if we compare our calculated value, which we are getting in the ANOVA table, so means if you are comparing with the tabulated F value, that is unstable tabulated F value, so your inference is maybe questionable, or maybe you may get the invalid conclusion. Okay, and the conclusion may be mislead you. So that's why regarding replication, we should say that we need that much of replication which will give you the at least 12 degrees of freedom for the error. Okay, so here I have given one small example, like for RBD. Suppose we are having 5 treatment and we want to conduct the experiment and in the field, that is in RBD design. So in that case, if you use 3 replication, so in that case your error degrees of freedom become 8. So in this case, if we include one more replication, so your this error degrees of freedom become 12. So in this case, so in this case we can say that for 5 treatment, if you conduct an experiment in RBD, we should take at least 4 number of replication, not 3, to get a we can say good result, or we can say the result which will not mislead you. So there is some of the list of designs or experiment I will explain in this lecture. So the CRD, RVD, LSD, these are 3 are the main basic design. Then we go for factorial experiment, then split plot, strip plot, and then combines or groups of experiment. So we already know this CRD. CRD we generally use in the greenhouse or in a biological experiment that is conducted in the lab condition. Why? Because for CRD we need the homogeneous experimental material. So I think maximum people participant, they already knows about those some basics, and someone may forgot it. So before going to the hands-on training, at least you should recall or refresh your these memories. So that's why I'm explaining it. So there is a for each and every design there is a model is there. So model indicates the different source of variation. So here we are splitting the total variation and into the different component variation in the ANOVA. So what are the source of variation that we can get from the models? So this is the model for CRD, and for in case of CRD, there is a source of variation is treatment. There is a source of variation is treatment, and the calculation of a SCMCD, I think all of you knows. No need to explain it. So next, I'll go to RBD, that is randomized block design. So randomized block design, it is most widely used in agricultural experiment. Okay, so the design we use when our experimental material are heterogeneous. So in heterogeneous condition, so there is one more condition is this, where fertility gradient are in one direction. So how will know this fertility gradient is one direction or 2 direction? So for this, we have to go for uniformity trial. So uniformity trial is nothing but a trial which is conducted before your actual trial. So why this uniformity trial is conducted? To know the fertility status of the soil. And it is done by using a one short duration crop in the field and then collecting the all the yield data from the field. After collecting the yield data, we'll draw a fertility contour map, and based on this fertility contour map, we'll draw means based on this fertility contour map, we'll have a idea of the fertility status of the soil. So based on this fertility status, we'll divide the entire heterogeneous experimental material into the homogeneous blocks. Okay, so how will prepare the blocks? If the fertility gradient is if the fertility gradient is in from left to right side, then we'll draw the block perpendicular to the fertility gradient. So for each and every experiment, we should carry out the uniformity trial. Though in reality, at least 90% people not conducting such type of trial, though it is very essential. The statistical model is yi equal to mu plus ta plus rj plus epsilon ij. Here extra one more or component is added in case of RBD. So here replication, that is nothing but is the blocks. So here you see, if you see in the source of variation, treatment and replication or block will be there. So next is Latin square design. So Latin square design we generally used when fertility gradient is in two direction. So now question is, if fertility gradient is in two direction, so in that case, how will prepare the blocks? So since fertility gradient is in two direction, so there is no possibility of preparing the blocks, because according to the principle of block, we should prepare the block in such a way that the block should be as homogeneous as possible, and there should be a heterogeneity between the blocks. So if fertility gradient is in two direction, so in that case, we cannot prepare the block. So at that case, we will divide our experimental material, that is our total experimental field, into different rows and different columns. So this Latin square design also called the row column design also. So in case of Latin square design, number of row and number of column and number of treatment, the three all should be same. If suppose means if we have a 10 treatment in an experiment, there should be a 10 row and 10 column. So among these three basic designs, CRD, RBD, and LSD, so LSD is the most efficient design. LSD is the most efficient design, though since also this LSD is not mostly used in the experimental field or in a greenhouse because of some limitation. Because suppose if you have a 10 treatment, so in that case, means we have to arrange 10 rows and 10 columns. That means each treatment are repeated 10 times in case of LSD. So same number of treatment. If you have a 10 treatment and if you conduct the experiment in the field, so in case of RBD, we can means we can conduct the same experiment in RBD with a minimum number of replication, with a 3 number of replication also. So due to this limitation, Latin square is not frequently used. So this is the model for LSD, and source of variation is treatment from row and column is there. So next is our factorial experiment. So when we will go for factorial. So up to this, we have studied the single factor experiment. CRD, RBD, and LSD are the single factor experiment. If you have a two factor and we want to conduct the experiment and with a two factors, in that case we have to go for factorial. So here we can say that more than one factor, if it is there, so we have to go for factorial experiment. So suppose we are having two factor, like one is spacing of a crop and different types of fertilizer or different dose of fertilizer. If you want to see both the factor together in a single experiment, so in that case only way to conduct a factorial experiment. So here we are not saying a factorial design, it is a factorial experiment. Okay, factorial is not a design, it is an experiment. So if you conduct this experiment in a field condition, we call it as a factorial RBD. If you conduct the same experiment in the lab, we call it as a factorial CRD. So there is a different types of factorial experiment, symmetrical, asymmetrical. Suppose if you have all the factor, suppose if you have two factors, both the factor have a same level, then in that case we call it a symmetrical factorial. If means if the this both the factor have a different level. Suppose first factor has a 2 level and 3 level. So when the level are not same, then we call it the asymmetrical factorial. So in case of factorial, there is one more advantage is there. So the main effect as well as we will get the interaction effect also. So yeah, if you see the source of variation due to block or replication, then main effect A, main effect of B, and their interaction. The process of calculation of critical difference. All of you knows, I think, this thing, split plot design. So next is split plot design. Okay. So when we use the split plot, suppose we have a two factor, and among these two factor, one factor require a larger area and require a smaller area. So in that case, we have to go for split plot design. So suppose the factor require a larger area, like irrigation, tillage, such type of factor. This means agronomical practice, or we can say the this type of practice, irrigation, tillage require. So we have to assign it in a main plot. Main plot means that plot, and within the main plot there will be a subplot. So factor requires like fertilizer, doses, or weedicide. This type of factor which requires a smaller area will subplot. So the precision of a subplot will be the compared to main plot. So sometimes based on the precision also we are deciding the which factor will be the in the main plot and which factor will be in the subplot. Some confused with the factor which require larger or small area. In that case, you can see importance of the variable, which factor you need it to estimate more precisely. In that, you can put that factor into the subplot. So this is the some basic layout. So there is a two main plot, M1 and M2. Within each main plot, there is a subplot. So main plot is occupying the big area, larger area as compared to the subplot. So that's why the we'll get the more precision from the subplot as compared to the main plot. So this is the model for split plot. So here we can see replication, then effect due to main plot, and there is a error one due to main plot. This error we call as a error one or main plot error. Next, this is the effect due to subplot, and MSJK, it is the effect due to main plot into subplot. And lastly, there is a error one, there is a error two, which we call as a subplot error. So if you see the ANOVA structure, in ANOVA there is source of variation due to replication, main plot, and error one, and then subplot, main plot into subplot, and error two. So in case of split plot, there is a two error. So this is the process of calculation of a critical difference for a split plot design. So these so those information you will get in any of the book. So strip plot design. So how you use the strip plot design? Actually, strip plot design will use when our experimental means when the both the factor require a larger area. Okay, like different method of irrigation or different method of applying, these two factors require a larger area. In that case, none of the factor or can be possible to accommodate in a small plot. So in that case, you have to go for strip plot design. And in case of strip plot design, our interaction effect, and we'll get the good estimate. Means we can say the precise estimate for the interaction effect. So this is the layout for strip plot design, and this is the statistical model. In case of strip plot design, we'll get the three error. So error 1 due to a vertical strip, error 2 is due to horizontal strip, and third error due to interaction. So this is the source of variation. See, factor A, then due to factor there is error, due to factor B there is error, and due to interaction there is error. There is a 3 error. This is the process of calculation of critical difference. So next come to we'll explain about the combine or pool experiment. So what is combine or pool experiment? Suppose in one experiment, if you conducted year after year, or you may conduct same experiment season after season, or you in same experiment means you conduct at different locations. So in that case, you have to means you have to give a conclusion based on the different location or different year. So in that case, you have to pull all the data, or means all the trial information, means over the year or over the season, and based on this data, you have to draw your conclusion. So this is very important. So before conducting the pool trial, pool analysis, you should go for individual site analysis. Suppose you have conducted one experiment in 3 locations. So before conducting the combined analysis or pool analysis for individual 3 location, you have to do the analysis, and you have to see the homogeneity of the variance. If the 3 environment are homogeneous based on the Bartlett's chi-square test or Hartley test, so you can easily do the pool analysis. Otherwise, you have to go for weighted analysis. So this is some of the source of variation, and for see here for simple RBD, I already explained there is a replication or block and treatment error. The three component was there, but in case of pool, suppose pool over the year, so there is a effect of year, then replication within year, treatment into year. So if you know the source of variation, so you can easily write the model in R. Okay, if you don't know the source of variation, so it is very impossible to write the means R model. Okay. So similarly, in case of factorial also, so these are the source of variation. So this is the split plot design. For split plot design, source of variation for split plot design, and how will write in R. Suppose there is a error, is the error 1. So how will get the error 1? Okay, so you will not get directly this error 1. Means when you will write the code in R. So for this in the model, you have to write it like this: ER into replication into main plot. That means that indicates the error 1. Whatever value you will get corresponding this ER into replication into main plot, that is your error 1. So one of the important thing is data transformation. So data transformation is very essential. Okay. So after conducting the experiment, and means you will collect the data, and after analysis, you may see that your data does not follow some of the assumption of this ANOVA. So there is a 3 assumption for ANOVA. So if one of the assumption does not follow means your data, so in that case, so you cannot carry out the ANOVA, means analysis of variance. If you cannot carry out the analysis of variance, then in that case you cannot do the means inference based on your data. So in that case, there is a one method called data transformation. So generally in our agricultural experiment, we generally these 3 commonly used transformation is there: square root transformation, logarithmic transformation, and angular transformation. So square root transformation, where we use the square root transformation. So suppose the means first we have to see the variance and mean of the data set. If variance is proportional to mean, then we can go for square root transformation. And second condition is the data consists of a small whole number. Okay, like insect count data, number of infested plant per plot, like this data, where there is a lots of zeros or small data will be there. So mainly count data, we can say mainly count data. So in that case, we should go for transformation or square root transformation. And sometime this percentage data also, we should do the square root transformation. Which type of percentage data? That percentage data either range from 0 to 30% or 70 to 100%. So I will do the square root of x plus 0.5. That is the formula for calculating the square root transform value. Next is logarithmic transformation. So in that case also, when variance is proportional to the square of the mean. If variance is proportional to the square of the mean, in that case our coefficient of variation become constant. So in that case, we should go for this log transformation. So it is used generally this length or weight at means number of egg mass per unit area, means generally we can set a growth measurement data. Okay, so that you can use log of x plus 1, log of 2x plus 1. Okay, instead of log x we should use. And lastly, angular or arcsine transformation. So angular or arcsine transformation we generally used for the data of proportion or percentage data. Okay, that percentage data, that suppose there is a percentage data like protein percent, fat percent, and some percentage data like this, like percent infestation. Okay, so these two different percentage data is not same. Okay, so here we should do the transformation for those percentage data which is derived from the count data. Okay, the percentage data which is derived from the count data, only those percentage data we should go for transformation, not others. Like protein percentage or fat percentage. So all those data we should not do the any transformation. So here we see the percentage data ranging either between 0 to 30 or 70 to 100%, not the both. We should go for square root transformation, that already I told. And for percentage data between 30 to 70%. So first you see the range of your data. Okay, if it is range between 30 to 70%, all the percentage data, then no need for any transformation. So because if your data range between these 30 to 70%, that automatically follows the this normal distribution or all the assumption of a normal distribution or ANOVA. And lastly, the percentage data which overlap the above two situations. That means which range from 0 to 100%. Okay, 0 to within 0 to 100%, and then in that case we should go for arcsine transformation. So this is the brief overview of different designs and some important portion of the regarding designs. Hello.
Hello.
So so is there any question regarding this up to this part? So I can start this hands-on training. Should I continue?
Session is open for the query. If anybody is having any question, please ask to Dr. Manoj.
Good evening, sir. So
Good
please
evening.
explain pooled analysis again. Please pull the design pooled analysis.
Okay. Okay. Any queries? Others?
If anybody is having any kind of query, please raise their queries first.
Okay. The pooled analysis means when you will do. Suppose if we conduct an experiment in different location, or we conduct the same experiment if we repeat it year after year. In that case, we'll we have to go for pooled analysis. Suppose for individual year, we'll get the some result. So suppose in first year some variety may be good, in second year other variety is good, and third year maybe some other variety good. So as a whole, if you want to draw conclusion that over the year or over the location, which variety perform best, for to want to know that So we should we used to go to pool analysis or combine analysis. So before doing this, before going to pool analysis, we should see the homogeneity of the environment. Okay, if environment, if you conduct the experiment in to extreme environment, okay, so in that case, it means it is not possible to make a conclusion and that a single variety is good. Okay, because some variety may good in this type of climate, some variety may be good in extreme condition. Okay, so if your environment is not environment is not homogeneous, in that case you can carry out the pool analysis with some weighted analysis is there, but before that you should conduct an homogeneity test. There is a Bartlett chi-square test is there and Hartley test. Okay, Hartley test is very simple. So whatever location or whatever year you have from the ANOVA, you see the error mean square, maximum error mean square and minimum error mean square. Means if you divide it, if you divide the maximum error mean square by the minimum error mean square, if it is less than 3, that means in that case we can say that all the environment are homogeneous. So you can carry out the pool analysis.
Thank you, sir. Thank you so much.
Okay. Okay.
Yeah. Hello, this is Dr. Supriya.
Okay.
On behalf of whole organizing committee, I would like to thank Dr. Manoj for such an informative and valuable session on this data transformation and design of experiments in such a detailed manner. Thanks, sir. Thanks a lot.
Okay, thank you, ma'am. Okay, now I'll go to hands-on training. So here, very basic. I'll go to very basic. I'll not go in very difficult coding. Okay, very simple coding here. I have written that code here just in a simple manner. Okay, so well, I'll try with CRD. So so this is the first example, CRD. So we have 5 treatment and each treatment are repeated 5 times. Okay, so this is the data arrangement. So so for analysis, okay, data arrangement is like this only for any software. Whatever you you use SPSS, R or SAS, whatever software you use, the data arrangement is same. Okay, so first you should know the data arrangement, means always you keep the replication one after one, not side by side. Okay, so this is the data arrangement for CRD. So previous speaker, Dr. Soumik, he has explained different method of importing data to the R file. So here, I will use one among this one of the method. In that method, I used to just copy the data. First, you just select and copy it. Simple. So after copying, the data will be in the clipboard only. So that's why. Here, read.table and data from where it is from clipboard and header equal to true. So you can write complete also TRU also. So in short also you can write. So that data will be saved in a there is a name called A. In this data will be saved. So first I will run it. Okay, so data is imported here. So if you want to see the data, there is a different method is there. You can just select it and just run it. So you can see the data here. Okay, this is shortcut method. So after importing the data, we have to attach this data file to this R environment. Okay, so for attach A, that file I am attaching here. Okay, so actually this one so here 2-3 times it came because already I have done other analysis also with the same name. So next, for seeing the data structure. Okay, for data structure, this thing also explained by previous speaker. So so what is the data structure? Data structure is there is a 25 observation with a 2 variable. That is, one is treatment, one is yield. Okay, so So anyone use SPSS, they can recall that in that case SPSS also we have to assign the factor. Okay, there is a fixed factor, dependent, some dependent is there, fixed factor, random factor, all these are there in case of SPSS also. So here also R also, so there is a two variable, treatment and yield. So R will not know which one is your factor. So you have to define it. Among these two, our treatment is our factor. So that's why you have to define it before going to the model. So here, here I am defining the treatment. That treatment variable I am defining as a factor. That treatment is it is in a file. Mean a dollar treatment means within a file there is a variable called treatment that I am defining as a factor. Okay, so I am defining it. So next, so there is a package called agricoli. So agricoli is generally we used for this multiple comparison test, that is essential for multiple comparison test. So I already explained the model for CRD. In CRD, you can see what are the source of variation. There is a source of variation is treatment. Only treatment is there. So that's why I wrote the model. Yield is our dependent variable. See here. In model, yield is there. This Y is the yield or response. We can say yield or response. And treatment is there is only one factor. So yield, then there is a treatment. This is the model. Okay, model for CRD. Very simple. So I'll run this model. And next, if you want to see the output, just we print this ANOVA model. So if you print it, see we are getting the, so right side we are getting the ANOVA model. There is a degrees of freedom, sum of square, mean sum of square, F values and probability values. Okay, and there is a significance. It is indicating the significance or non-significance. But means by seeing the probability value only, we can identify it. If this probability value is less than 0.05, we can call it is a significant at 5% level. If it is less than 0.01, we can call it is significant at 1% level. So next, actually here means we got the treatment are significant. So from the ANOVA, we can say that treatment among these 5 treatment, there is a 5 treatment are there. So among these 5 treatment, there is a significance difference, but we cannot explain which treatment are differ significantly. Okay, among these 5, which treatment are differ significantly among themselves. For this, we have to go for multiple comparison test. There is a different multiple comparison test like LSD test is there, Duncan is there, Taki is there, Bone Ferron is there, so many other tests is there. Okay, so this LSD when we generally we use LSD, Duncan or Taki test. Okay, mostly you will see these 3 tests are using in a research, in agricultural research. So when you will go for LSD, when you will go for Duncan, and when you will go for Taki test. So generally LSD will use when our treatment we can say treatment are small, like 3 or 4 treatment or 5 maximum, we can use the LSD test. And Duncan when will use, the Duncan will use when we are having the means more treatment like 10 or more than 10. So in that case, we should go for Duncan and Taki test. Okay, when your treatment number is large, more than we can say 8, 9, 10. So in that case, we should go for Duncan or Taki test. And among the Duncan and Taki you should use where we need the more precision. Okay, like in a laboratory experiment. In that case, we need the more precision. So such type of experiment, for such type of experiment, we should use the Taki test. Okay, so now we'll run this package called agricoli. Okay, this call is agricoli. Agrically not found. Acha. We should run it like this. Okay. Agrically is there. Okay, I run it. Then we'll see the first. I'll run the LSD. See here. If you run the LSD here, so here we are getting the mean square error. Mean square error that is will get from the ANOVA. Then degrees of freedom, mean, then coefficient of variation, then t value. So this t value for what purpose we require? We require to calculation of CD value, that is LSD. You can say it LSD also. LSD means here this LSD, it is not a Latin square design. It is the least significance difference value. Okay, least significant difference value. If we multiply the standard error of difference, that is SED, into t value, we'll get this LSD value. And you'll see here there is a grouping, LSD grouping, that is since there is a significant difference, so there will be a grouping. So A, B, B, C, and D. Okay. So I think for a particular design, for expressing or for giving the conclusion, this much output is enough. So I think for CRD, this is over. Next, I'll go for RVD. Okay. So there is one, we can see treatment. There is a 12 treatment. 12 treatment is there, and each treatment are replicated 3 times. That means you can say there is a 3 blocks. This is the data set. So I feel comfortable to import the data in this way. Just copy paste, copy again. First the same procedure. So so after copying, the data will be data is saved in the clipboard only. So that's why I'll run it at us. Then at us A, because same name is there, so it is attaching one so many times. That's why this this red is coming. It is not issue. Next, we'll see the structure of the data. Okay, see here there is a 36 observation and 3 variable for 3 variable each: treatment, replication, and field weight. Okay, so among these 3 variable, we have a 2 factor. Treatment and replication both are a factor. So we have to means we have to define this, because they don't know which one is a factor, which one is a variable. So that's why we should define it before running the model. So here within the A file, there is a treatment variable is there, which I assign as a factor. Similarly, in A file, there is a replication variable is there that I assign as a factor. So there is 2 factor I define. After defining the factor, you can write the model. The model. So here I have written treatment plus replication. So yeah, so if there is a 3 factor, then plus 1 more, like this we have to write it. Okay, so that's why I told, if you know the model, okay, if you know the model of any design and source of variation, so you can write, and you means you can do your analysis by yourself only. So next we'll go to model, run. Then I have to, for seeing the this output of the model, I have to run this. Okay, I have to print. You can print it. So here you see treatment, application, and residual. Residual, that is error. So here you see that treatment are significant. If treatment are significant, so there so here we have a 12 treatment. So among these 12 treatment, which treatment are differ significantly with themselves, so we have to go for multiple comparison test. So next, for multiple comparison test, we'll see the LSD. See here. So your LSD value means CD value. CD value is 7.35. CV value is 11. 11.10. Actually, in case of agriculture experiment, or that is in field experiment, generally your CB should not be more than 10 to 15. Okay, as a thumb rule. Okay, there is no specific guideline is there, but as a thumb rule, it should not be more than 12 to 15. And for lab experiment, it should be less than 6 or 7. So if CB is more means there is a problem of there is a problem in your experiment. Okay. So for any experiment, so you should always mention your CB value. So by seeing the CB, we can easily identify if there is a problem in your experiment or not. If there is a more CB value means there is a suppose one treatment is replicated 3 times or 4 times. That means there is a more variation in the replication as compared to your treatment. So that's why your CB is increasing. So similarly, we can see the Duncan grouping also. This is the common for the Duncan test. Okay, see, this is the grouping. This is the grouping. This is the again we can run for Taki test. This is the grouping. So I think you can interpret it. So I'll tell a brief. So see your symbol. By seeing the symbol only, you can see the means you can differentiate it. Same symbol indicates there is a no significant difference between the treatment. If any symbol common among the treatment, that means they are not significantly differ. Suppose this is treatment number 9 and suppose treatment number 5. Treatment number 9 and 5, these two treatment are significantly differ among themselves. But treatment number 9 and treatment number 8 and treatment number 10 up to treatment number 7, there is a no significant difference because symbol A is common up to this. Okay, so like this you have to interpret it. So before going to other design, so I will explain some other thing for RBD. Okay, like someone may require that means when you will do the experiment. Okay, so there will be so many variable. Okay, not a single variable. So here single variable. Suppose for a field weight FW. Okay, this is your variable. This is your variable, and these are your factor. If you have a more factor, more variable like suppose plant height, yield, variable. So in that case, how will run the code? Okay, so this is big, we can say slightly complicated, but I will tell you this. Okay, I will explain this thing for our video. Okay, remaining same thing you can and you write yourself. Okay, for this we have to write a loop. Okay, here loop. SPSS, it is very easy. For a single variable, we'll go for univariate. If there is a multiple or a dependent variable, we'll go to the multivariate option. Easy. But in case of R, there is you have to write a loop. Okay. So this one I'll show you here. First, I will explain it. So this thing is common. First, we have to import the data. This file to the R environment. Then for seeing the structure of a data, we will write this. Then we have to define the factor. These two factor will I am defining it here. Okay, two factor defining it here. Then see the traits. Traits indicates column within A. In A file, the column 3 to 5. Okay, 3 is our variable. If you have a 20 variable, 30 variable, in that case, see, file, when we'll import it to the R environment, this is the number one variable, this is second, third, fourth, and fifth variable. Okay, this is the first, second, third, fourth, and fifth. So our dependent variable, that is which the variable will analyze, that is third variable, and it is end with fifth. It is end in the number. So that's why I write here trait, or trait is equal to columns from 3 to 5 that lies within a file. Okay, I think you got it. Next, you see here loop, one loop, loop I am writing here, for loop, that is called for loop. For I in 1, it will start from 1 to length of a trait. Okay, length of a trait. So see here now, model equal to, instead of giving a dependent variable name, okay, instead of giving a dependent variable name, see here, I have given the name FW. So since we have only one variable, so that's why I have given you directly the name of that variable. So now we are having the multiple variable. So in that case, so see here, I have given the trait I start from where? I start from third variable. Okay, and it will end with variable number 5. Okay, so you have to give this range, okay, before writing the model. So what this loop will do? It will take the first variable, that is y1, that is third number variable. It will take, then it will do all the analysis. Again, when I become 2, it will take the variable number 4th. Again, do all the analysis within, see, this model will be in the second bracket. Okay, when you will write the any loop, then that loop means whatever action you want, you should write within this second bracket. So that means whatever command is there inside this, it will run for your first variable. That is when I equal to 3, it will run the first it will run the model. After model, whatever grouping variable is there, whatever value calculation, everything it will do. Again, it will go to second. Then again it will go to until it comes to variable number 5th. Fifth variable comes means your that loop will automatically stop. I think you got my point. So
Yes, sir.
okay. So now here, see here, means I have just modified a bit here. See, you can write your own coding in your own way. Okay, how you want to see your output? Okay, how you want to see your output? So here, means I just make a list of means whatever output is there. I just make a list. Okay, one after one. Yeah, it will show is like this. So what does it mean? List. In this list, I have given the first. It will show the ANOVA table. Then from ANOVA table, it will show the statistics of LSD. Then SEM value. Then it will show the mean value. Then the LSD grouping. Okay. I'll just mean whatever output is there. Okay. Means when you write the code, big code, in that case, so many output will come. So among this output, which output you need and in which range? Okay. First, I need that. Then this chronological way. So you can make a list, and then you just print that one. Very simple. Okay. So first, means I will run that code, then you'll get the better idea. Okay. So here also same procedure. I'll just copy it. I prefer this way. Okay. So these things are common. First, I'll just clear it first. Okay. So I just run it, then attaching. So it will attach so many things. Okay. Then I see the structure. There is a 30 observation with 5 variable. First 2 are your factor, and last 3 are your dependent variable. So first 2 we should define as a factor. a treatment as a factor, replication as a factor. Now, that trait, how many traits you have to analyze? 3 to 5. 3, 4, 5, 3 factor you have to analyze. And your that trait is start from third variable. Okay. So this one you should define it previously. So that package we need, agricoli package we need. So now, see here, we will run this code. Okay. I run it. What it is showing? Error in DF1. Browser not. Error. Model AOP trait I treatment plus application. Okay. Print okay. Print rate okay. LSD dot model tier 3 that okay. Okay, within replication. Okay, we can take it. No issue. See, root of one. Okay. Okay. Try this. That I okay. This one I think. Let's see first. I length of 3 to 5 model. R equal to TF. Where is TF? Okay, just this one I just make it automatic. There is a one what to say subset there is a one subset was there. Okay, so while preparing this I just delete that command. So for time being, instead of this I'll just directly write the replication. Okay, here for time being I just you can take it means automatic. Okay, so for some experiment you may have 3 replication, for some experiment you may have 4 replication. Okay, so in that case that command will help you. So now for time being I means here I am directly giving the r equal to 3. Okay, see here we have a 3 replication, 3 or 4 3. Okay, for time being I am giving it. Okay. 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 So now this one for time being I'll just stop it. So see here output, same output like previously. See here it is giving only. So now I'll run the loop. This is I run for one variable. So now I'll run the loop. So here you will get all the 3 variable together. Okay. So first output is for variable 1. So for differentiating between the variable, I just give a one dot line. Okay, so that is up to you. For that will this is differentiating from one variable to another variable. Otherwise, if you have so many variable, you won't be able to differentiate it. Okay, it will take time. So that's why see here for first variable, see this is the output. All the output are there. This ANOVA table. Then there is a CD value, SEM value. This see SEM value, it is not coming automatically. Means when you will do means directly. Previously I have done it. In this there is no SEM value. So if you want to calculate the SEM value, you can simply write the formula like this. So for SEM only, I need the replication. So that's why I put R equal to 3. So actually there is a, you can you can make a subset from the ANOVA, means what is the degrees of freedom for replication. Then you can add the one with the degrees of freedom of replication, that become your number of replication. So likewise, I prepare it, but means while preparing it for training, I just remove it. I think that's why it was not working previously. So here you can directly write the R equal to 3 also. It does not issue. Okay. So now see the this is the first variable. This is the your second variable output. All the output is here, and this is the third variable output. Okay. So now question is, suppose if you have a 50 variable, okay, if you want to analyze 50 variable together, so in this so one thing I will tell you before this. So you can just copy it. Okay, you just copy this output and you can paste it in Excel or in text file. Okay, you can copy and you can paste it. So if you have a means more variable like 50 variable or 60 variable or 100 variable, in that case this output, so it is not visible all the variable. Okay, last some variable you may visible, but remaining you won't be able to see it. So in that case, what will means what you will do? So in that case, there is a way you have to export whatever output you are getting here. It will save in a separate file in different locations. So for this, there is a command, call it sync. Okay. So previously I just stopped this command by giving the hash. If you put hash in any command before the any command, so that command will not run. Okay. So you can write so many command. Okay. So among these, some command you may not need for the time being, but you may need it in future. In that case, you just give a hash. Suppose you just give a hash before that command, so that means whenever you will run that code, that command will not run. Remaining all code will run, but except this code. Okay. So now you see, I just run the that sync command. So where my file will save. So my file will save in a desktop. See, you have to know the all the path. So I will know the path. Suppose if see, I am saving this in a this lecture training folder. Okay, in this folder I want to save. If you click it here, you'll see the path. See user, my name, then desktop training lecture. Okay, so here you slash is see here like this, but you have to give the slash in opposite side in R. See, in this you have to give the slash in opposite side. Okay, like this you have to give the slash, and this output will save in a, and you have to give the output file name. Up to this we have seen the this folder location. Okay, folder location, then you give the output file name where the output will be saved. Okay, so then I run this. I run this. So first I remove all the output here. So now when I run this, when I will run this, so there means in this console you will not get any output. See, all the means so here I can see only the code only, no output. Then after completion, you should close the sync. Okay, if you don't close the sync, so whatever work you will do in this R environment, all will save in this, all will automatically save in this output. Okay. So once you start the sync, and you have to stop the sync. So now, so my output is saved in this folder, training lecture folder, as a RBD output file name. So now if we see, RBD output is there. See, it is saved here. Okay, for variable 1. for variable 2, for variable 3, all are same here. So it is very easy way. Okay. So if you don't need any of the output among these, so you can simply stop this. Okay. Or here, see, if you don't need any output, you can delist it from here. Okay. You can delist it from here. Suppose I don't need this LSD statistics. If I remove it from there in the output, it will not show. Okay. So it's totally depends on you. So this is one of for how to do for multiple character and how will save the output in different location. And one more thing I want to explain here, that some of the sometimes you may need other parameter also, like those who are plant breeding genetics people, they need some heritability, the GCP, PCP, all these things, different parameters. So for this also, you can write your own code. Okay. Here, means if you write the formula, once you know the formula, you can write one after one, and in the stat, in the list, you put it. Okay. In the list, you just put it and print it. It is very easy. So here I have written a code for this. Okay, all the like you see here. See, these things are all same. All same. You see, importing, import first data import, then make as a factor, then that fight sync command is there. Then this what to say, loop function is there. So within the loop, so whatever output you want to you want to generate, so write all the formula and function within the loop. Okay. So here, see, R equal to 3, and see genetic variance, phenotypic variance, standard deviation of genotypic variance. Then you can say GCP, PCB, heritability, genetic, advanced genetic gain, all these things, whatever you need, everything you can write. Okay. Just if you know the formula also, it is available in the books or in net. Okay. So if you know the structure, structure format, so I had to write it, so you can easily write. Okay. So if you want to see the output of this, so you want to see this output, I think is okay. I'll show one output for same data. One thing I have to first here, I have given treatment as an entry here. Okay, just remember whatever you are writing here, so it should be same. So previously I have given name as a treatment, so here I'll give as an entry. Since it is related to plant breeding and genetics, that's why I have given name as entry. Copy. Then I am just taking the data. Same thing, making these are the factor. Then the trait is you want to analyze is 3 to 5. Then there is a, see, there is a one package I have written here. What does it mean? Easy package. Okay, that means, see, here is only one package. Sometimes for analysis you need multiple package. Okay, like some big coding, for big coding, for different step you need different types of packages. So every time for writing library, okay, see here how I am writing library agricole. So if you need 10 package, so you have to write the 10 line for this library agricole, library that. So like this, for reduce this code, you can use this command. Okay, easy package. Within the package, how many packages you need? Just write the name all the packages. Yes. One after one. Okay, so it will reduce the length of your code. So I'll run it. and sync. I'm syncing it and I'm saving it as a RBD output 1. Okay, RBD output 1. And just running the loop. So this loop is running successfully. There is no error. So next I have to stop the sync. I stop the sync. Now I want to see the output. See RBD output 1. Output is came. So if you compare the previous one and this one, same data, up to this much is same. Okay, this portion is same. Extra what we got? These parameters we got. Okay, what are the parameter? This standard SEM though is already got CP. This genotypic variance, phenotypic variance, GCP, PCP, heritability, genetic gain, and GEM, genetic advance in percentage of mean. So all these things we got extra. So if you need any other thing also, you can include it. Okay. So same thing you can do for all the other design also. Like for LSD. Next I come to LSD. This is all our simple coding. Okay. LSD. See here. In LSD there is a 3 factor. One is due to row, column, and treatment. So in model you see treatment plus row plus column. Okay, yield equal to treatment plus row plus column. So that's all. Remaining are same. You have to change. See, if your design is changing, you have to change the model only. And whatever component in the model factor are there, you just define it as a factor. That's all. Everything will be same. Only model will change. And see, these portion are same for all. I think for this, no need to run. Then come to two-factor factorial analysis. See here, two-factor factorial analysis, same. This first will import the data, then data sheet, then you want to see the structure. Then here we'll define the factor. Same procedure, replication as a factor, FYM as a factor, and PSB as a factor. In the model, you see here. So till now we have done for single factor. So if you have a two factor here, so first is yield equal to model replication plus first factor plus second factor plus their interaction. Okay, how will writing interaction? First factor colon second factor, that is interaction. So only this much. If you know the model, you can do all the analysis. If there is a three factor, then write the three factor model here, and whatever factor are there, you just define it here. Only that's all. And remaining here, this grouping and all. For which factor you need the grouping? For first factor, for second factor, and if it is three factor are there for third factor, so you will get it from here. And if you have a more variable, then make a loop, same loop for so once you know that loop, you can apply it for all the design, same loop. And for sync command also same, you can sync the output to other folder. That's all. So no need to explain this loop and sync for all other design. That's why I didn't mention here. Okay. So next we'll come to the split plot design. See here, split plot design, same. See, 80%, 80, 90% code are same. Once you know the one design, so remaining design, at least 90% code are same. Only model and factors are different, and slight some other difference based on the design. So here also we just defining the factor. Here we are just importing and attaching. This is common for all. Then for while writing the model, see here while writing the model, if you see split plot, split plot. Acha, here for pool. This is for pool. Okay, simple split plot I will show you. See this. So if you compare this, see, once you know the source of variation, that is coming from your model only. Okay. See here, first replication. I write here yield equal to replication plus main plot. Our main plot is there. Then plus replication into main plot. So actually in an ANOVA there is a error one. So how will get this error one? The error one is the just interaction between replication and main plot only. Okay. If you multiply the main plot with replication, that is called error. So that's why here I written replication into main plot. Next is your subplot. There is a subplot is there, and lastly interaction is there. Okay, main plot into subplot interaction. For this error one, no need to write any code. This automatically will come after the analysis, after the ANOVA. Okay. So once you know source of variation, you can easily write the model. So remaining are same. Okay, see, print model. This is for common. This for the grouping. LSD grouping is there, but here one small problem is there for in case of split plot due to the number of error. See here we have a 2 error. Here we have a 2 error. So how so here how we are getting the F ratio? I think we all knows F ratio is the mean sum of square due to main plot divided by error ms. So this one we know. So here in case of split plot, software is automatically considering the error 2 as a only error. So that's why software is dividing this main plot ms by the error 2, not by error 1. That's why there is some problem. Okay, so you have to we have to rectify it here. Okay, and whatever this for in case of subplot and in case of main plot and subplot, there is no problem because it is taking it needs only error 2. Okay, main plot ms divided by error 2 means error ms2 you can say, and this is main plot into subplot interaction ms divided by error 2 ms. Okay, so now come to our code. See here, problem you can easily see what I am saying. Okay, I'll just run this code. Okay, first, then you can easily identify it. Problem. See, this is the data. I just copy. So, is it okay? Or any? Is it audible? Hello.
Yes, sir.
Yes.
Okay. Okay, then see, I'm running it. First, I have to import the data. Next, attach. Then we have to see the structure. So next, we have to make this factor. You can just select and run also all together. There is so many ways. So now I will run the model. Okay, I explain it model. Then I print the this ANOVA. See here, replication, main plot, subplot, then main plot into this is replication into main plot. That is your error 1. Okay. So though this in this output, this is not in a chronological order. Actually, first replication, main plot, then error 1 should come. So you can arrange it. Okay. By so you can modify this sequence. Is up to you. So here the result is not means this result will not be different. Okay, means for the what to say, for aesthetic only, just for seeing. You can modify the output also. So here, see here, replication into main plot is your error 1. And the main plot into subplot, this is the interaction, and this residual is your error 2. Understand? So here you see replication into main plot. Error 1 ms is 0.659 and error 2 ms is 5.362. So now we'll run the your this LSD. Okay, in that we will see the LSD value. Okay, we'll see the LSD value. See, first we will calculate the LSD for main plot. So I'm running it. Now you see this.
Sorry.
For calculating the for main plot, so the software is using whose mean square error. For calculating the CD value, we should use the mean square or error 1. But software is using 5, that is for error 2. Okay, that is for error 2. So for this, you have to calculate it in a different way. So this is the problem, I'll tell you. But for subplot, there is no issue. So we run it. So if you run it for subplot, so for subplot, our LSD value is 2.29. So it used this mean square error 5.36. So now for calculating the mean square error LSD value for main plot, this code. Okay, that means see here this AOB matrix ANOVA model. So first what we are doing, we are converting model in a matrix form so that we can pick up some of the same of the observation from this, and we can utilize in the further calculation. So first we convert it into the matrix form, that model. Previously, Dr. Soumik also explained regarding the matrix and all, and how to convert the data into matrix form. So next, so I am picking the mean square error. Okay, from that ANOVA, I am taking all the mean square error. This mean square error. So actually for calculation of a CD value. So I am just subsetting it. Okay, as a MSS. And similarly, degrees of freedom also I am taking it from here separately. So next is degrees of freedom for error 1. What is the degrees of freedom? Error 1. So that error 1 degrees of freedom also I need, because see this is bit different from the previous code. Here also LSD.test main plot and group equal to true. But here you see LSD.test is okay, function is, but within the function the option are different. Here you have to specify the which variable you want to analyze here, and for which factor, what is the error degrees of freedom for this, what is the mean square error for that. Everything you have to give here information. So that's why if we so whatever information we need, identify it. Okay, so I will just run it. You can identify it. I'm just running it. See, if you want to see it, A or B, just select and run it. So now it is in matrix form. Okay, now it is in matrix form. So now we are picking the MSS, mean sum of square. So if you want to see how it look like, see, among this table, AOB table, I just took only this portion. Okay, all are same, only this mean square, this column I just pick up. Similarly, I will pick up the degrees of freedom also. Okay, I pick up it. Then from these degrees of freedom, this DF subset, I have taken the error degrees of freedom. This is our error degrees of freedom. Then mean square error from the MSS. Okay, and lastly, I just run the LSD function here. See here, this is the LSD value. LSD value means CD value. and it is using the mean square error 0.65, not a, see here, for main plot it is using 0.65. 0.65 is the mean square error for main plot. Previously it used 5.63, which is the, see here, for main plot previously it used the 5.36. So likewise you have to rectify it. Okay, and lastly I'll just explain the code here for pool analysis. So see, this is the code for RBD pooled analysis. So here, see, this portion is same, and here we have a one more extra factor, that is ER. If it is location is there, that factor you have to include that location. Instead of here, there will be location. That also factor. So here we are defining the factor, same like previous. Next we are writing the model. Okay, here we are writing the model. So uh, what are the source of variation for this for full analysis? I have written. I don't know. For pooled analysis, see here, what are the source of variation? For simple RBD, there is a replication, treatment, and error. But for pool RBD, there is a error. First is year, then replication within year, treatment into year, then error. Okay. So once you know these, what are the component, so you can write the model. So here our variable, suppose yield, maybe yield or maybe plant height. Here in example there is a pH data is there. So now see here, year, here first year plus replication within year. Okay, replication within year. So we can write it like this, or you can write in a by giving the colon also. Both will give you the same result. Okay. So replication percent in percent, that is replication within year. Next is treatment plus treatment. Next treatment into year, that is treatment colon year. Then this last error, this error will automatically come. No need to write any command for this. Okay. And next, a similar way you can get the LSD. So if you observe all the code, so only you have to modify the this this model, and whatever extra factor if you are including in the design, you just define it in this portion. That's all only. Or every design you can do, whatever design is there you can do easily, and you can carry out your analysis. Okay. So I think from my part is enough. It's okay. So any doubt?
Please raise your hands one by one.
Hello, sir. Is
Hello.
Yes, sir.
hello?
Hello.
Sir, actually, I'm doing research work and my model is my design is double split plot design, sir. So I would like to contact you. May I get your contact number or mail ID, sir?
Yeah. From them you can get it. Yeah. In
Okay,
case of
sir.
double speed also, you just see the
Uh-huh.
model and just very easy now. You can easily write your own code. Okay. If any
Okay, sir.
doubt is there or writing this model, you can contact. Okay.
Okay, sir. Okay, sir. Thank you, sir.
Mm.
There is any queries? There is any queries? Yes, Benjamin.
Hello, good evening, sir.
Good evening.
So actually, my question is just in a basic question only. Actually, so I just want to ask this one. So, like, so why we are using our studio or digestion still when we can calculate like ANOVA and all, SPSS and all? Is there any like some difference between these two? I just want to know this one, sir. Like, why we are focusing more on R and all instead of
Okay.
SPSS and all? Like, what is the main advantages of using R other than the SPSS and all, sir?
Okay. Have you seen the SPSS output? I think you
Yes,
have
yes.
used. So in the output, if you compare the SPSS output and R output, so in SPSS output, whatever they have included from the company, that only you will get. But in R, whatever you need, based on your need, you can modify. Okay, and means whatever you want to include, whatever you want to analyze, everything you can include. Okay, even you will not get those CD value and all these things directly in SPSS, but in R you will get the CD value and others. Okay, directly you will get.
Okay, sir. Okay, thank you, sir. Okay, sir.
And one more thing I want to include here, SPSS is actually you have to buy it, and R is a free software. Okay, it is
Yes.
open source software. That is most important. Though you have analyzed in SPSS also, if you don't have the license, okay, so you cannot write in your any published work or any thesis dissertation. Okay, so you should not write it. So there will be issue of copyright or okay.
Okay, sir. Thank you, sir.
Hello.
Hello.
Any other query, sir?
Sir?
Please raise your hand. Tharun.
Yeah, Tarun. Yes, sir. Sir, actually, loop is there, na, sir? Loop function.
Yes.
So can I use that loop function for visualization, like mapping or any graph laying, like that function? Can it be used for any other visualization, something like that?
Means you want multiple graph within a single command by using single command.
Yes, sir. With a single command, I want to compute number of graphs or number of mappings, like visualization part. Can I do that one?
Actually, for graph, there is a such type of means what to say, package is not there, but yeah, you can write your own loop. Okay, you can write your own loop. Means by using that loop, you can create so many graph in a once in one code. Okay, you can write the graph.
Okay, that structure will be same like this, sir, like the command structure. Or do we need?
No. For this loop will be different. This will be different.
Okay.
Any other query? Please raise your hand. Tarun, please make your hand down. Please make your hand down. Okay. Any other query? Sir, as there is no more query, so we can end the session. So I would like to thank Dr. Manoj for such an informative lecture and the entire team organizing the FDP program. We will be meeting tomorrow at the same timing. The link for the meeting will be provided to you. All the video lectures and their recorded versions have been provided. The PPTs, especially for all those who are giving the PPTs, if the candidates are allowed, if the lecturers are allowing, we are allowing the PPT. In fact, my PPT would be provided to you today by itself. I'm just editing it, finalizing it. Okay, sir, please do share the codes. There is a request from Poonam Kanwar to share the codes. I will.
Okay, I'll share it.
Yes, I will request Dr. Manoj to kindly send the codes and the PPT to Dr. Ashwani, who will be sharing all the information in the group. Okay, sir. Sir, with these words, I
Okay.
would like to end the session as we have already passed the due time. So that's all for today. Hope you all
Okay. Thank you.
session.
And good night.
Thank you, Manoj sir.